Good afternoon, everyone. Welcome to today's webinar presentation. This is the continuation of the Developers Webinar Series. This is number 4 in the series. The Orchards at Orenco Phase 1 team is on the line with me. That project is in Hillsboro, Oregon. In case you missed the first 3, they're available online, and we will distribute that link in our follow-up email after the event has concluded. Please take a look at your control panel. There's an option to ask questions. Please go ahead and enter those as you think of them during the session, and we will tackle those in the last 15 minutes or so. And with that, I would like to introduce our presenters for today. They were involved in the Orchards at Orenco Phase 1 project. I have Jessica Woodruff, the Housing Director at REACH, on the line, and also we have Craig Kelley, Senior Project Manager with Housing Development Center, on the line. Jessica, Craig, welcome.
Thank you.
Thank you.
So, like she said, my name is Jessica, and I've got Craig here with me. I thought I would just start by going through what our goals are and kind of how. Oops, sorry, I'm having technical difficulties. Sorry. So, kind of start with how we got here, and part of it too. I just wanted to explain the relationship between Craig's company and my company. We have a long history together, and REACH, we are the owner, developer, and manager. And then Housing Development Center acts as our owner's rep. So really, I just thought I'd explain that Craig is really a sort of an extension of our development department. So we work really closely together, and I thought that just might help to understand when we go through the presentation. So how we really started was we are part of a national group for nonprofits that do affordable housing all across the nation, called the Housing Partnership Network. And in 2010, our executive director at the time, Dee Walsh, went to Europe, to Germany, and toured a number of passive house projects. And she was really inspired by what she saw there, and she came back and talked with our board of directors and our senior staff and said, I don't know why we're not doing this. It really doesn't seem very hard, so go do it. And the board got excited about it, and generally the company was excited about it for a number of reasons, most notably because our mission is to provide affordable housing, and at that time we really were thinking broader than just rents and thinking about the utility costs and transportation costs. So this started to become a potential avenue for us to make a bigger impact on our mission. So I wanted to just show this slide of the development team so you could just see how many people it took. Of course, for us in Oregon, there was nobody who had done this except for one of our team members, which was Green Hammer, but they had only done it on single-family homes or much smaller multifamily. So it took a cast of characters spending a lot of time together, so I just like to show how many people were involved. And that leads into some of the things we'll talk about later. So this project in particular, I wanted to just show, and this kind of fits into what I mentioned about our broader goals of affordable living. So the project the project is we bought 6 acres of land in the suburbs, a city called Hillsboro, Oregon. And what's important about this suburb is it's actually the fastest growing suburb in the state, and a lot of that is really driven by Intel, which you can kind of see the Intel land at the top of the slide. Intel is the largest employer in our state, and so we were able to get 6 acres of land at our light rail station. And that became a goal for us to put this passive house project there because, again, we could kind of hit all of our goals, which are to reduce total household bills for our residents, including energy, rent, and transportation. So I also wanted to show the master plan of our 6 acres because although those are our goals, there were some things about the site that made all of our goals a little bit challenging here. One, the phase 1 project, which we're talking about today, Craig will talk a little bit later, but the city zoning and planning commission requirements required that we wrapped the site on 2 sides, which caused us a little bit of challenge. And then additionally, the parking code at this transit stop is pretty crazy for us. For the rest of the metro area, which we operate in, have much different parking codes, but this city has a very high parking code, which is 1.5 spaces per unit, even though it's at a transit stop. And then just really quick, so the project is 57 units total. 40 of those are 1 bedroom, 17 are 2 bedrooms, and all of the units are at 50% median family income or below, and that equates to roughly $30,000 or less per year income. And I wanted to show the sources and uses of the project here and just kind of give a highlight. We'll go into a little bit more detail later. But just note that this did cost us extra, about close to $1 million extra. And so if you look at our sources and uses, what for us in affordable housing is typical are the top 4 sources. And then when you get down to the Meyer Memorial Trust, those are all unique sources that we were able to bring to the table for this deal, most notably the $500,000 from Meyer Memorial Trust, which really was to help us meet this goal. And then the others that were just what we were able to assemble to pay that premium, and then a breakdown of how we use that money. And I'm going to pass it to Craig.
Good afternoon. This is Craig Kelley, Senior Project Manager at the Housing Development Center. The Housing Development Center is a nonprofit that works with mission-driven organizations such as REACH to develop affordable housing and community facilities. Our role in the project, as Jessica touched on, was the owner's representative, helping to coordinate also then some of the energy incentives that came along with the project. So to kind of frame the conversation, the team held a charrette at the beginning of the process and identified a savings goal of 70% over a typical apartment, large savings in the heating energy, the domestic hot water, cooling, and lighting, because those are really things that Passive House can help address. One of the big unknowns was around the tenant behavior, and we'll talk a little bit at the end if we have time around some of the strategies there. So I think this will be a quick review for many of you, but just the Passive House approach is really trying to look at cost-effective energy reductions. Kind of the way I like to look at it, since I have young kids, is eating your conservation vegetables before you start talking about any sort of renewable cookies. So really trying to look at how do you reduce the load on the building, optimize the efficiencies of the systems. It was developed by a German physicist in the 90s and really focusing on the envelope so that you can reduce the heating loads and cooling loads. And another way to kind of frame this is that you have sort of one real opportunity to invest in your building envelope that's going to be your shot at reducing 40 to 50% of the building's energy use. So how can you most cost effectively reduce those loads, look at details, look at design that will maximize that energy reduction over the lifespan of the building. Oh, there we go. Sorry, had a little glitch there. So again, one of the things that I like about Passive House is that it's performance-based. It's not a prescriptive path. That creates challenges and opportunities, really. And one thing here is that this was certified through FIAS prior to the new 2015 standard coming out. So we'll be talking about PHPP and things like that since it was under the old protocol. So it's really looking at these three key criteria around heating energy, source energy, and air tightness, and having that air tightness field verified. We worked really closely with the contractor and the rater on that air tightness piece, and certainly that was one of the biggest unknowns for a building of this size with some of the commercial code requirements and how to address the air tightness for some of those commercial components. So just going into a little bit of detail on the certification process, we did certify through FIAS. The Passive House consultant, Greenhammer, was engaged from very early on, so from the charrette, really at the concept stage, all the way through the project. They ran numerous iterations on the model. Our FIAS Plus Rater Earth Advantage performed the on-site inspections, and I think it was a learning curve for both Greenhammer and Earth Advantage, as Jessica touched on. It's just a much bigger building than any of the team was used to working on. We were pre-certified by groundbreaking, and I think that was really important for us as the owner-developer, just to have that certainty, knowing that FIAS had reviewed all of the models. We had some technical challenges that we had to work through, that they got the technical committee involved in, and knowing that at groundbreaking we had the pre-certification, so it was a simple matter of just building the building as it was designed, which really wasn't that simple, but having that pre-certification in place, I think, was a lot of peace of mind for certainly me as the construction manager. And then we received final certification right at the end of construction, a few weeks before occupancy, after completing our final blower door testing and the commissioning of the mechanical system. So to elaborate a little bit on the building itself and the design, so it's a 3-story wood frame building. It's on a corner, as Jessica touched on, so certain things such as solar orientation and the amount of envelope to volume were really being driven by the city's planning guidelines, requiring a certain amount of street frontage. The other challenge, I would say, working in this jurisdiction is they have very strict planning guidelines related to building design. It's a new urbanist town center, and so they have a very craftsman aesthetic with a strong desire for a lot of building articulation and ornamentation, and so that created some challenges to meet Passive House. It's not as, I'd say, simple of a building form as would be ideal, but kind of given the constraints, I think the architect did an excellent job of finding a middle ground. So drilling down a little bit, you see here a conceptual diagram of the building with some of the main strategies that we employed. So high performance windows, there were more meetings and discussion about windows than I think Jessica will ever want to hear about again.
Correct.
We actually did a field trip up to the window manufacturer in Vancouver, BC, and I really would say that the windows drove a lot of the other assemblies, and that was really the key decision, and so there was a lot of analysis that went into picking the right window. Other real key strategies was a highly insulated roof with heat recovery ventilation, super insulated walls, fully insulated slab. And then the other, I'd say my biggest concern on the project was actually the building overheating in the summer. We don't have true air conditioning, and with the long north-south orientation, I was very concerned about overheating, so really trying to look at what strategies we could employ to have shading, which we could use horizontal shading for the south elevation of the building, but any sort of external shading or vertical shading on the west wasn't really going to be allowed by the jurisdiction since it didn't fit into the craftsman aesthetic that they were going for. So I'd say last summer was the first summer the building was fully occupied. Of course, it was leased up during a heat wave, and I think the building got hot and took some time to cool off. I think this summer will be a little bit more representative, hopefully both with weather as well as not having a bunch of residents moving in. So just a little bit more detail on the design. So the fully insulated slab R19, including thin layers of insulation about an inch underneath all of the structural footings, which I'd say our structural engineer was very much on board with. The geotechnical engineer and the concrete crews were a little bit skeptical, but the general contractor did an excellent job of, I think, working through any questions or challenges there. Exterior wall, I think it really speaks to kind of the iterative process that we went through. The general contractor and and Green Hammer spent a lot of time trying to optimize that wall assembly. It's a 2x10 wall with 1.5 inches of exterior insulation, so trying to find an assembly that a production framer could build cost effectively. And then an R81 roof, 12 inches of polyiso insulation there. So I think really what to me made this project successful was the team, and I think Jessica can add her perspective to this as well, but it was really having all of those core team members present from the very beginning. So Reach having that commitment and really setting that goal, the design team being on board, working very closely with the contractor and the subcontractors and the energy consultants to try to work through some of the technical challenges as well as the budget challenges that come with this innovation. I think one of the key things there was holding a charrette very early on in the process, and it got very detailed, but it also, I think, set the tone for the team to really look at what those key concepts and key details might be. And then from that charrette, it was a very highly iterative process of conceptual design, modeling, cost analysis, constructability, and there was a lot of rinse and repeat as part of that process. So this is just kind of an example of that schematic design, and you can see kind of all of the iterations that the energy modeling and the team went through to try to identify the key components, target R values, and then the contractor would look at costs associated with that, come back through. I honestly lost track of how many iterations we did, but I think it was in the 30s somewhere. So a real commitment from all of the team to try to find a successful, cost-effective, energy-efficient solution. I'll just touch on some of the building construction challenges and opportunities. So cost, and we had a lot of research into specific products the windows, the ERVs, some of the commercial doors. Just the products that were needed are available in Europe, but were at that point not readily available in the U.S. And so a lot of time spent trying to find what's going to be most cost effective. And then the general contractor spent a lot of time looking at constructability, a lot of time with quality control, looking at some of these atypical connections or details, trying to keep them as constructible as possible, but then also eliminate thermal bridges. So it was very, Walsh Construction, the general contractor, did an excellent job of that constructability quality control process. A lot of coordination work with the subcontractors and the sequencing of the work. I won't get into details, but just we were doing some of the work out of sequence, and so a lot of thought had to go into how to build the building, how to sequence all of the various trades. And then a very extensive quality control process from the general contractor during design, during bidding, making sure that all of the scopes were covered, trying to make sure that the subcontractors weren't overpricing some of the newness. So really trying to get buy-in from those subcontractors. Extensive coordination during pre-construction, submittals, mock-ups, and then working. They had a dedicated passive house specialist. Skin doctor is also the other term that they use to really maintain that quality control of both their own crews as well as the subcontractors, and then close coordination with the FIAS rater on how to sequence the blower door testing, the other quality control, third-party inspections that the FIAS rater is required to do. So touching on the actual performance of the building, so the target was a 70% savings over an average building, or about a 55% savings over a code building. And you see that the design model was an EUI, Energy Use Index, of 22. We've got about 5 months of data now, and we're just slightly above that goal. So I think we're feeling like the building is performing very close to predicted. One of the things that we're still researching, so here's another slide kind of showing some similar information. So one of the things that we're still in the process of researching is the systems are actually performing below the model, but there's a large load in the common areas that we're still trying to determine if the elevator, or we had to add an emergency communication system or some other system, is performing significantly over what was modeled. So overall, the building's performing. I think there's hopefully some refinement and some lessons learned as we, do the warranty walk and do some almost retro commissioning of the building. Sorry, there's a little lag here with the slides. So how much does all this stuff cost? So as Jessica touched on, REACH brought in about $1 million of additional resources. The premium was about $150,000 for soft costs, primarily on the design and sub-consultant side. So both the architect, mechanical engineer, energy modeler, and passive house consultants. So those costs were about $125,000 of incremental costs over what we would expect to pay. And then the certification cost itself, both for FIAS review fee as well as the Earth Advantage FIAS Plus rater on site. So those total to about $150,000. On the hard cost side, The bottom line was about $900,000 of additional costs. Kind of the big ticket items on this laundry list were the windows and doors were about $175,000 premium. The air infiltration costs, so when we got down to it, a lot of what was involved was tape and sealant and a lot of labor, so a lot of time for detailing that air barrier. Up at the top, there was additional general requirements, so both additional duration as well as the additional supervision and quality control. So there were both direct costs for labor and materials as well as indirect costs for supervision, quality control, and additional time. One other thing I'll point out on this slide, and we can come back to this if there's questions at the end. So on the HVAC system, it sort of depends on what you assume is the baseline. So for this project, we assumed a baseline of a package terminal heat pump, and the mechanical system that we used with energy recovery and a heat pump was pretty much cost neutral. I think depending on what you use as your baseline, you could see a premium for your HVAC, but I do want to point that out.
So this slide again just kind of goes through and gives a breakout of the sources and uses of just this passive house premium for us. Just going through what Craig just talked about of the just over $1 million in premium costs for us. And then also all of those sources I mentioned at the beginning that we committed to either fundraising or committed ourselves. We put $300,000 of our own money in to try to achieve this beyond the most of the other sources we have in a typical affordable housing deal are our taxpayer resources or somehow tied into public resources, so we wanted to keep this out of that. So I'm just going to go over the sort of the key lessons learned, and these are, you know, I definitely highly agree with all these lessons learned, but these are also just kind of input from the entire team of how we felt like we learned. Like I said, we said it was an integrated design team from the beginning, so we all we went through all of this together. So the importance of establishing the vision early and having a specific goal was really important. As I mentioned, that for us was our executive director at the time going to Germany with the Housing Partnership Network and coming back and saying, this is something we can do, it's something we should do. She also, and with our board of directors, determined that, you know, at the first there was a lot of talk of how much does it cost and what's the payback analysis. And she pretty clearly said, if we're going to do something that's innovative, we know there's a cost to innovate, so we're not going to look at it quite that way. We'll look at it that way later, but not on this first try. And then the importance of having the commitment from the decision makers. So again, everybody knew that this was the goal. We knew it wasn't going to be easy, but we were all on the same page. And I would say an important key about that too is this took us a long time from when she came back to Germany until we started construction, that many times this didn't make sense to us. I mean, when we looked in our normal ways that we do pre-development and determine if a deal makes sense, and in a lot of ways it didn't make sense except from a mission standpoint. So it was really important to have everyone just know, keep working, we'll get there. We put a lot of extra time into that. Selecting the right team. So as owner, I can't highlight this one enough. So when we looked at even those soft cost premiums, I know that that doesn't reflect the true hours put in by each one of those firms into figuring all of this out. We spent an ungodly amount of hours talking about certain things like the windows, which Craig teases me about because I couldn't stand it anymore. But we just kept going. Things didn't make sense, and we just kept pushing, just kept learning. And so having the right individuals is just, you know, I can't say enough how much I think that's what really made this deal happen. Designing with Passive House at the forefront. I think in our case, we did that on one hand, but we also had a site that didn't work perfectly with Passive House. So I think the earlier any team can be deciding that they want to do this and then be even looking for land and teams that are all aligned with that, I think that just helps make it go smoother. The integrative, iterative design process, I think I've said enough about that, but I think that was key to our success and not having big problems later that we had to go back and resolve. Early construction team involvement. Again, on this project, we had a lot more people involved than typically. We had the subs in to meet with the whole team a lot more. So just a lot of extra time and energy spent together as a team. And then learning from others. So the Stellar and the Kiln project are Oregon projects, so we learned a lot from them, but we also had others, most notably in Pennsylvania at the time, through our housing partnership network group that all went to Germany, that we were learning a lot from others, and that's part of why we want to share what we learned. For example, the pre-certification, I mean, that came from a different team that didn't do that and really regretted it and told us we should, so we learned from others all along the way. And so this is a picture of Craig, since you can't see him. So part of it is it was hard, and so we talk about needing to have a sense of humor, and Craig luckily does. So we would call him the grumpy cat when he would start, worrying us that something wasn't going right. So we tease him about that, and he's a good sport. And this also just to me reflects the team. So this sign is something that the site superintendent for the construction company put up for the subs, because he wanted to just set a tone that he didn't want to hear from them anymore, that's normally not how they would do it. And so it really took every level, not just the highest level of people at the companies, but all the way down to the site, of course. And then this is just something we like to show and think about of kind of where it's come from. So I have to say we're very proud that we were the largest passive house built in North America when we opened last June, but that was also never our intent, and we didn't want to stay that for long. So we like to just see, when we started really working on this, it was in 2010, and we felt sort of like there was a movement going on, and I think this slide just reflects what we're seeing locally and what we hope everybody else is seeing. And then lastly, just wanted to do a little bit of brief discussion about our phase 2. So we very much feel like phase 1 is a success, but we did not want to pay the premium that we paid in phase 1. So we wanted to take the cost of innovation out and figure out how we could do phase 2 more at the normal cost. And now that we had learned a lot, could learn from phase 1, so Craig's going to go through a little bit of that.
So as Jessica touched on, phase 1 was really about innovation and REACH being committed to bringing in additional private resources to pay for that innovation. And we knew that that was not a sustainable or replicable model. And so really trying to look at what we learned on the first phase and how we can optimize it so that we can do passive house or passive house inspired on a typical affordable housing financing structure. The other thing that came into play between the two phases was that the state of Oregon Housing and Community Services implemented cost containment limits, and so even had those additional private resources been available, the project would not have scored competitively for the low-income housing tax credits. And so it was imperative to find the most cost-effective solutions. So one of the big changes was the design response. So we initially anticipated that phase 2 would be essentially a mirror of the phase 1 building, but both for reasons of parking as well as cost containment, it went from an L-shaped building to a linear bar-shaped building. And what's interesting about that is we went from 57 units in a 57,000 square foot building to 58 units in a less than 50,000 square foot building. So it was really trying to squeeze all of the efficiencies out of the space planning. That did also require some fewer amenity spaces. So, for example, Phase 1 has a community room that will serve both Phase 1 and Phase 2. So part of it was programming, but a lot of it was trying to optimize the design. So just kind of some quick high-level numbers. So Phase 1 had a total development cost of $14.5 million. Phase 2 was almost $900,000 less and almost $20,000 less per unit. But what's interesting is the hard cost actually went up if you look at it on a per square foot basis. And I think that was one of the things that I've thought a fair amount about is how do you talk about, cost per unit versus cost per square foot, because, even though we're serving more households, it's a significantly higher cost per square foot for Phase 2. But I think the right denominator is really looking at how many units and how many households you're serving. And similarly, on the energy performance side, the EUI, Energy Use Index, I think is going to actually be significantly or somewhat higher on Phase 2, but I think the actual energy per person is going to be really comparable just because the square footage of the building has been reduced. The unit mix and unit sizes are very, very comparable, 1 and 2 bedroom units. So it's really looking at those common spaces and trying to maximize and optimize those. And this just goes into a little bit of detail I won't cover, but you can look at later just as far as how we tweaked some of the systems for the envelope, roof, and some of the other assemblies. And I think with that, we'll go ahead and open it up for questions.
Okay, great. I have a few questions in the box here, and I want to encourage anyone else who may have questions to please start inputting those. Let me kick off with the first question. Okay. Did code require plumbing vent stacks to go through the roof, or were you able to get a variance to use all air admittance valves inside instead?
So yes, code required the plumbing stacks to go through the roof. We did not look at the air admittance valves. What we did do is we brought up those plumbing stacks into the trusses in the attic and then consolidated those to minimize the number of penetrations up through the roof, air barrier, and insulation.
Okay, next question is, what other thermal bridging issues came up as challenges? Thermal breaks used at balconies, for example.
So I'd say we looked at thermal bridging on every connection. I'd say some of the solutions that we came up with was using a clip for attaching the brick ledger at the base of the building. So it was a standoff clip rather than having that continuous steel ledger attached and the thermal bridge associated with that. For the deck connection, we looked at a couple of different options and ended up having a intermittent wood block with then the insulation between that intermittent wood block and a ledger attached through that wood block to carry the decks. One of the other details, thermal bridges that we spent a lot of time with was looking at the head flashing for the windows, and we actually have a special PVC head flashing that we had to get shipped from Europe through the Panama Canal to Texas and then on a train, and that actually almost hung up the construction schedule. So we ordered that very early on Phase 2. But again, it's one of those, the process is really looking at every one of those details and thinking through is that how that detail is best done to eliminate thermal bridging, but then also getting the reality check from the contractor and the trade saying, is that buildable? And is it buildable on our budget? So it's very much an iterative process in trying to come up with the best solutions to meet both energy, cost, and constructability.
Thank you. And then our next question is, what is a SAM, S-A-M, seen on some of your details in prior FIAS presentations?
Self-adhered membrane, also referred to as peel and stick. So it's it's what we use to detail a lot of the transitions at the foundation and then at the top of the wall. So it's a peel and stick self-adhered membrane.
Okay. Next question asks if you could discuss the challenges of the GC's workforce in adapting to the job site practices.
So I think a lot of the tone, the slide that Jessica showed about, you know, the sign that the superintendent had up in the trailer was really setting the tone that, you know, normally I know you do it this way, but the drawings and the details say do it this way, and that's how it's supposed to be built. So I think it was really key that the superintendent set the tone for the field crews. I think the other piece that was key is that the general contractor self-performed some of the work, so they had their own concrete crew do all of the footings and under slab installation, and so that gave them greater control for that detail, as well as they used their own carpenters to do all of the air barrier for the walls. So very close coordination alignment between the general contractor being able to use their own forces for some of those key details, and that was a very conscious decision on the general contractor's part to maintain that quality control. I think as far as other trades, I think it was interesting that a lot of them would sort of initially grumble, and then you would talk about kind of what you were trying to achieve, and at least for some of the trades, there was a real then sense of pride that, okay, well, this is different, but at least I understand why it's different. And I think in particular, after all of the attention that the project has gotten, I think there's a real sense of pride from certainly the superintendent and the field staff that, you know, here's what we've achieved, and there's a lot of pride that goes along with that.
I would say, too, in terms of talking about how important the team is, so, you know, the general contractor in our case was, I would say, was almost a visionary of part of what we were trying to achieve. They had a lot more staff on site than we work with this general contractor all the time. They had a lot more staff present, and like Craig said, I think when they were telling people what to do, they told them why. And so people, there was a real sense of when you went to the site of what the team was trying to achieve and helping educate people along the way. And we did hear from other developers early on that they had general contractors that weren't buying into it, and they were running into all kinds of problems. So I can't, you know, say enough how important the general contractor really feeling sort of part of the mission focus and wanting to achieve this was critical to us.
Okay, our next question asks, did you use ERVs that served multiple units, and did you insulate air seal between units?
So the mechanical system is 3 ERVs. Those are located in mechanical pods on the roof. So if you look at the aerial shot of the building, you can see kind of 3 penthouse pods on the roof, and each of those ERVs serve between 18 and 20 units. So we do have a single ERV serving multiple units. One of the smart things that the mechanical engineer found was a code exception to allow smaller diameter ducts to serve individual units and eliminate fire smoke dampers. So using that code provision was a big cost savings to eliminate all of those fire smoke dampers, even though, or not all of them, but 90% of those. So even though those ERVs are serving multiple units, we have direct home runs for both supply and return for that ventilation. And then as far as air sealing between units, I'd say it was sort of a typical approach to the air sealing. So sealing the plate, putting putty pads around electrical outlets, things like that. But really the focus on the air sealing was the envelope, not necessarily between units. And that's actually one of the changes that we're looking at for phase 2, because for the new protocol there is a requirement for air testing of the individual units as well as the entire whole building.
Thank you. The next question was kind of a repeat of that. Looks like there's a lot of interest in the air for the individual units. Also, if anyone else still has questions, please go ahead and enter them. Christina's is the last one on the screen right now. She asks, you said HVAC achieved cost neutrality on this project. Was that including the ventilation system that provides fresh air with heat recovery, or was that just the packaged heat pump systems with the ventilators being additional cost over conventional construction?
So the cost comparison was a baseline system of a rooftop exhaust in conjunction with package terminal heat pumps for heating and cooling. So that was the baseline system for cost and actually for energy modeling as well for some of the energy incentive dollars. And that was compared to the mechanical system of the 3 ERVs plus a single heat pump that's on the roof. And so the general contractor analysis was that that was cost neutral when you look at the ventilation plus package terminal heat pumps versus the ERVs plus the single multi-zone heat pump for tempering the air, the ventilation air.
All right. That's all I've got in the question box right now. Craig, Jessica, any final words of wisdom?
I mean, I think really all I would say from our perspective is, as kind of scary as it was at times, I think we are extremely thrilled that we dedicated to working it out, and very excited about the results that we're seeing. The tenants love it. It's very quiet. They talk about how safe they feel there, how they're excited about their utility bills, which they're responsible for paying. And so we're very excited, and why we're working on phase 2 being passive house as well. So we hope it catches on more and more.
And I guess I would just add to that I think it was exciting for us to be blazing some new ground on this project, but it's even more exciting to be hearing about some of the even larger projects that are happening, in Kansas City and New York and other places across the U.S. And we were the largest passive house certified project at the time, but I think that's going to be short-lived, and I think that's really exciting that others are really taking up the charge.
Yeah, that actually segues very nicely into my announcement for our next installment, which will be with Jonathan Arnold of Arnold Development, who is working on that Kansas City project. It's called Second in Delaware, and he will be joining us on May 17th to share how that project's doing.
And I would say we met with him when he was out in Portland, and what he's doing is very exciting and inspiring to us. So we hope people who are interested join that.
Great, awesome. Jessica, Craig, thank you so much for joining us today. Thanks for spending your time educating us on a very, very lovely passive building project. And we hope to hear more on your continued project progress.
Thank you.
Thank you.